welcome to 1-2 Systems of Equations. This time we're solving by substitution. So go ahead and write down the title, 1-2 Systems of Equations by Substitution. Put your name, that top right-hand corner, and today's date. And then below our title, we'll start with our learning targets. And just to remind you, you can push pause anytime you need more time to write something down, and then push play when you're ready. So our first learning target is that I am learning to determine solutions to systems by substituting. And I am learning to solve systems of equations by substituting. So the big thing with substitution is that this means today we're going to solve it algebraically. And what that means is that we're not going to graph today. So we're still going to look at solving systems of equations using just algebra instead of having to graph it on a coordinate plane. So now with our systems, we still end up with our three types of solutions. So solutions of systems are still those three types, except today they're going to look different because where we're going to solve them algebraically, we won't be able to look at the graphs. We'll have to look at our answers. So the very first type is one solution. If you think back to graphing, that's where they do intersect, and it is a point of intersection. So we write it like a point, xy. Now, the way that will look today is you'll end up solving an equation, it looking like x equals 2, y equals -3, and then having the ordered pair as your x value is 2, your y value is -3, and that's your answer. Our second type of solution we can get is no solution. And if you remember from graphing, no solution is when your lines are parallel. There's no point of intersection, so you put the circle with a line through it for no solution. Now this is different. It's going to make you think back to Algebra 1 for a moment, because you're going to have, now algebraically you'll end up with a step somewhere along the line. It looks like 2x minus 2x equals 8 minus 6. So 2x minus 2x is just 0, because 2 minus 2 is 0. You don't have to show the x, because 0 times x is still 0, and so it's just 0. 8 minus 6 is 2. And you have to ask yourself, is that true? Does 0 equal 2? No, it doesn't, because 0 has to equal 0. So since that statement is not true, and it is not equal, so not equal, it is a no solution. So you put a circle with a line through it, box it in, that's your final answer. And the last type of solution we can see is infinite solutions. And remember from graphing, infinite solutions is when we have the line that ends up being the same line and we put the infinity symbol. Now for this one, it looks a lot like no solution, but it solves out differently. So you end up with a step that looks like 2x minus 2x equals 8 minus 8. So this time, we remember 2x minus 2x is 0 equals 8 minus 8 is 0. So since that is true, 0 does indeed equal 0. That is true, it's infinite solutions. So that's your final answer we put. So those three different types of having a point, no solution, infinitely many still occur algebraically. Now let's look at how to solve systems by substituting. So the very first thing we have to do is make sure one equation is solved for one variable. And when you think about it, that means that one variable is alone, it's isolated. So all those different words also work. So you want to make sure it's solved for one variable, or that one variable is at least alone on one side or isolated on one side. All of that means the same thing. Step 2, and here's where you have to pay close attention to step 2. We're going to go back to the name of the game today, substituting. So we're going to substitute. Remember, substitute just means we're going to replace. Oh, it jumped on me. See if you'll go back. There we go. Substitute. The value for the variable and that's step 1. So where you have your variable isolated into, and this is the most important part, other equation. So anytime you substitute a value for a variable, you have to make sure you put it into that other equation in the system. Alright, step 3. We're then going to solve for the remaining variable. So if you think about it, at step 3 here, where we solve for that remaining variable, we're only going to end up with something like y equals 2. So if you have just one variable solved for, that means we're going to have to substitute again to find the other variable, just find x. So once again, name of the game is substitution, so we're going to substitute again. So substitute, or remember that just means to replace, the value for a variable. And remember, that's the value at step 3, into original equation. Now the last little part here, so if we solve for the other variable here at step 4, so when we substitute that value for the variable from step 3 into original equation, we're going to then solve for other variable. And when you do that, then you have like your x equals 3. So then, if you notice, like you then have a y value, you have an x value, so your last step here is to write answer as, and then we either want to write it like the order pair x, y. So for like that one, it would be positive 3, 2. Or you want to write the no solution if that's what you got. Or, I don't know why I put a comma instead of the word or you're infinitely many. Some of you all may have noticed I had a slight magic just a second ago because I realized I did not have enough room to write out all of my step 4, so those of you all noticed, good job. Now, let's see these steps in action. So, example 1. So go ahead and take a second. Remember, all we do is just write EX for example. Let me scoot this whole guy over a little bit. So EX for example, and then 1. And go ahead and write out x equals 4, and then 2x plus 2y equals 16. So first things first from our steps is we have to make sure one equation is solved for one variable. And if you look, this first equation has x isolated, x is by itself, so x can therefore be replaced with 4, since, and I like to say it a lot of times this way, x is 4. Now step 2 says substitute the value into the other equation. So I'm going to now change this x and replace it with the 4. So replace or substitute the 4 into x in our second equation. So instead of saying 2 times x, it's now going to say 2 times 4. Because remember, side by side means they're being multiplied, so now it's going to be 2 times 4 plus 2y equals 16. Alright, now we're told to solve for the remaining variable. So my only variable left is y. So to solve for y, I'm going to have to first multiply. 2 times 4 is 8. Plus 2y equals 16. Now our solving equation skills come into play. So to solve for y, we're first going to have to transpose our positive 8 over here and make them a minus 8. So 2y equals 16 minus 8. 16 minus 8 is 8, so 2y equals 8. Divide both sides by 2. And y equals 4. So for this one, I now have y equals 4. Well, my step 4 says to substitute the value for this variable, step 3, for its value, into one of the original equations. But if you look at the original equations, this one already tells me x equals 4. So I already have the value for x. Now I have the value for y. So the last step is to just write our ordered pair since we have a solution. So our solution to this system would be 4 for our x value, and then 4 for our y value, so xy. There we go. And that is our solution. We're all set with this first example. So let's see another example. So example 2. Let's make this just a little bit bigger here. That way we can see it. So we got y equals 3x, and then x plus 2y equals negative 21. So go ahead and write out that system. Remember, step 1 is to make sure we have one equation solved for one variable. And we do. If we look here, we have y is isolated. So y is alone on the left side here, and he equals 3x. So step 2 now says that I can replace the value for y, 3x, into the other equation. So I'm going to replace this y with 3x and substitute 3x into this y. So now I'm going to drop down my x plus 2. Instead of saying 2 times y, so I'm going to say 2 times y is 3x equals a negative 21. Now we want to reduce it and solve for our remaining variable x. So we're going to say x plus 2 times 3x is 6x equals negative 21. A little something to remember from Algebra 1 is that if you have just a regular old x, it actually has a hidden 1 in front of it. So it's 1x plus 6x, which is 7x, equals negative 21. We're still solving for our variable x here, so it needs to be multiplied by 7, we divide both sides by 7, and we get x equals negative 3. We have our x value. Now we have to look at step 4 this time and substitute this value for x into an original equation to solve for y. So if you look, I'm going to grab this first one because it's easier because y is already by itself. So I'm going to say y equals 3x, and this time I know that x can be my negative 3. So y equals 3 times x is going to be 3 times negative 3. 3 times negative 3 is negative 9. So I have x equals negative 3, y equals negative 9. I can write my final answers in order pair. Remember, x always comes first, so negative 3. And then our y, negative 9. Negative 9. And that is our final answer to that system. So it's substituting, then substituting again. So the first thing we substituted was we replaced y with 3x. And then over here, we replaced x with negative 3, so we replaced that x with negative 3. And then the rest of it's just solving equations. So let's see another one. So example 3. Go ahead and write out this system. We have y equals 4x plus 3, and y equals 2x minus 15. So the first thing we look at to see is if we have one variable solved for. So one equation with one variable solved for. And if you look, this one we do. We have y equals, by itself, 4x plus 3. But if you look down here, I also have y by itself equals 2x minus 15. Now here's the cool part about this one. I really like these type because we know that y equals y. We know that part's true. Y equals y. So we can actually take what they're equal to and set them equal to each other as well. So I'm actually just going to replace this y with the 2x minus 15. So y is now going to be my 2x minus 15 equal to what that first y equals, 4x plus 3. 4x plus 3. So we said the y equals y is true, so then we can take these two parts and set them equal to each other. And it doesn't matter which way you can do it. You can put your 4x plus 3 over here and your 2x minus 15 over there. It doesn't matter, as long as they're set equal. And now that we have both equations set equal to each other, we're going to take our variables to the left. So 2x is already over here on the left side. Bring over our positive 4x, make him a negative 4x. Drop down our equal sign. I always like to try to keep it in line with the other one. We have our plus 3, so positive 3 on the right. Our minus 15 over here to become a plus 15. And now we're going to simplify. So 2x minus 4x is a negative 2x. 3 plus 15 is 18. Divide both sides by negative 2. Negative 2's cancel, and x equals 18 divided by negative 2 is negative 9. Now that we have x is negative 9, we can replace one of these x's up here. So I'm going to grab that first equation. For this one, it doesn't matter whether they're both set with y equals. So it doesn't matter which one you ever grab, they both will solve out correctly. It's just one's usually a bit easier, but in this case they're the same because they both start with y equals. Now we're going to replace this x with the negative 9. So it's going to be y equals 4 times x is going to be 4 times negative 9 plus 3. 4 times negative 9 is negative 36 plus 3. Negative 36 plus 3 is negative 33. And now our last step is to write our answers in order pair. So x always comes first, so negative 9 and 33. Sorry, negative 33 for our y. Quick little statement about this solution is that think about if you were to graph both of these linear equations on a coordinate plane, they would eventually cross at negative 9, negative 13. So rather than having to make a coordinate plane that big, we just solve it algebraically. Alright, and now for our last example. And now to our last example 4. So go ahead and write this out for me. We got y equals 6 minus 3x. So I'm sorry about that. It's y equals 6 minus 3x and 3x plus 2y equals 48. So remember, step 1 is to make sure we have one equation solved for one variable. If we look at this first one, we have y by itself, so the top equation is already solved for y. And now it equals 6 minus 3x. So down here we can replace this y with your 6 minus 3x. I'm going to make that my symbol a little bit better. It kind of threw me off before. I guess when I wrote it before I had a little smudge in there. So we're going to replace this y with our 6 minus 3x, which means we're going to drop down our 3x here in front of that second equation, plus 2 times, we said y is now going to be the 6 minus 3x, equals 48. Alright, so now we solve it for x. So first thing we got to do is worry about the parentheses. Those are not like terms, so that means we got to distribute. So we drop down our 3x here in front, because he's not involved with that parenthesis. We say 2 times 6 is 12. 2 times negative 3 is negative 6x, equals 48. Next step is to combine our like terms. So we have 3x minus 6x here on the left side, so that'll give us a negative 3x. Drop down our plus 12 equals 48. Now to solve for x, we're going to have to transpose our plus 12 to the other side, make him a minus 12, so we end up with negative 3x equals 48 minus 12. 48 minus 12 is 36. Now the last step to get x by itself is divide both sides by 3. Sorry, negative 3. So divide both sides there by negative 3. And x equals a negative 12. Now to solve for y, we're just going to replace x with negative 12 into one of the original equations. This one right here is easiest because once again y is already by itself. So we say y equals 6 minus 3x. And we're going to replace this x with a negative 12. So y equals 6 minus 3 times a negative 12. Y equals 6, and now that's, always use that sign in front, so that's actually a negative 3. So negative 3 times negative 12 makes a positive 36. 6 plus 36 is 42. So we got y is 42. Last step is to write our answer like an order pair. So our x value is negative 12. Our y value is positive 42. And we're all good. There's our final answer. And that finishes our notes up for today.